let's take an first example of finding the volume. So write down, find the volume of the tetrahedron bounded by the planes y0, z0, x0 and x by a plus y by b plus z by c equal to 1. Right? So let's draw in rough a tetrahedron. It's a three-dimensional. Maybe it is difficult to draw for me. But see, let's try. This is x, y and z. So it's a three-dimensional thing. And you have to find the volume of this, right? So you have to find the volume of this tetrahedron, which is bounded by these three axes. So this will be my total region where I have to find the volume. So let us consider a three-dimensional we need to find the value of the limits, right? So now we draw an elementary volume, right, where we draw a volume. This strip is called AB, for example, which is parallel to my z axis, right? By mistake I've written here y. So this is parallel to my z axis and it terminates at the plane, right? If you look at it, it terminates at the plane. So limits of z clearly will be z is equal to 0 to z is equal to, now x plus, the plane is x plus a plus y by b plus z by c equal to 1. So if I find the value of z, that will be 1 minus x by a minus y by b. So z is equal to c into 1 minus x by a minus y by b. So my upper limit is c into 1 minus x by a minus y by b, right? So now your z limits are done, right? So now the region will be converted into two-dimensional. So if we look at this two-dimensional, it will be a vertical strip which will terminate on the line x by a plus y by b equal to 1. Okay, so in the same thing, this is eliminated. So the line is x by a plus y by b equal to 1. So the limits will be y 0 to b into 1 minus x by a. And lastly, x is simple. It is 0 to a. Right? So now my volume, you know it is in the Cartesian form. The formula for volume is triple integration of dx, dy and dz. Right? So which is volume? Now 0 to a, 0 to b into 1 minus x by a, and the innermost limits 0 to c into 1 minus x by a minus y by b. First we will integrate with respect to z because limits are for z, then for y and then for x. So let's integrate with respect to z first. So with respect to z, the integration is z, and upper limit minus lower limit, you will have b into 1 minus x by a. So you will have c into 1 minus x by a minus y by b dy dx, right? So now let's integrate with respect to y. Next integration will be with respect to y. So let's integrate with respect to y. Now c is a constant anyway. So 0 to a, c will be as it is. I'll take c outside. So one integration will be y minus x y by a, and this will be y square by 2 into b, right? and limits of integration are 0 and b into 1 minus x by a. So if I simplify this is 0 to ac. You can take these two terms together. So that will be y into 1 minus x by a minus y square upon 2b. The limits are 0 to b into 1 minus x by. So in place of y now, let's substitute my upper limit. So that will be 0 to a. I can take c outside the integration anyway. So that is b into 1 minus x by a the whole square minus b square upon 2b 1 minus x by a the whole square. Okay, this is with respect to x. So b minus b square by 2b, we can take that b outside, so that is bc by 2. 1b will cancel from this, so that is bc by 2. And after you integrate this, that will be minus a 1 minus x by a the whole cube by 3, and the limits of integration are 0 to a. So after we substitute the upper limit and the lower limit, the answer of this will be a, right? So my final answer for the volume is ABC, sorry, by 3 is also there. So ABC by 6. This is my final answer for the volume. So the sum is too easy if you look into it properly. The integrand becomes anyway, we don't have anything inside. So it is dx, dy, dz, and you can easily integrate. Okay, so let's take another sum. Find the volume cut off from the sphere x square plus y square plus z square is equal to a square by the cone. So a sphere is given and a cone is given. X square plus y square is equal to z square. Okay, let's try. If we imagine this, we can also imagine. First you take a globe like a sphere and then a cone is fixed to it. Okay, so let's try to imagine this. Suppose this is my x, y and z axis. I'm so sorry. Okay, so let's draw the x, y and z axis. And then you have to draw a sphere. So sphere will be something around here, a three-dimensional thing. Okay, this is three-dimensional. You imagine that it is three-dimensional, right? And then they have given that a volume cut off with a sphere by a cone. So cone will be something around here. So cone again is a three-dimensional thing, right? So volume cutoff means a common region we can see. Okay, so something around here. So again you take a strip and you try to find. So if you take a three-dimensional this thing, okay, it will be something like this, not very exact because drawing this becomes difficult for me. So this thing is x square plus y square is equal to z square, right? And this sphere which we have drawn is x square plus y square plus z square is equal to a square. So now we need to find the volume, right? The volume formula is triple integration of dx, dy, dz. This you know very well. But now since we have seen in the last lecture what we have seen, whenever we have triple integration and the limits of integration are not provided, there is a simple way to do it. What we did in the last lecture, find the value of z. the value of z in this case will be what? One value of z will be under root of x square plus y square, and another value of z which it touches up will be x square plus y square. If it shifts, that will be a square minus x square plus y square. Again, that is in under root, right? So let us find the limits of z. The limits of z, you know that down it touches the cone. So limits of z, that will be under root of x square plus y square. And here the limit of z will be a square minus x square minus y square. dz. Okay. So what we are doing, again, the same logic which we applied in the last type, that first we will integrate with respect to z first, and then my triple integration will be converted into double integration, and you can convert that curve into polar form. Okay, so that becomes very easy then, instead of using my any other coordinates. Okay, so now my triple integration has been converted into double integration. And if you look at it now, x square plus y square is equal to z square. And you know that z square is equal to x square plus y square. So if you look at it properly, that will be a circle. So the region of symmetric, if you draw the region of symmetric, this z square value, if you substitute, this becomes a 2x square plus y square, which is nothing but a square by 2, right? So that will be a circle, of course. If you can look into it, if you convert into double this thing, that will be a circle, and circle is a by root 2 if you look at it properly. So this is nothing but where R is a circle. What is that circle? X square plus y square is equal to 2x square plus y square. So that 2 will go over here. Okay. So that is a by root 2. So my x square plus y square will be r square. So now I will convert this into my polar coordinates. So I'll name this as equation 1, right? And then converting it into polar coordinates, substituting x is equal to r cos theta, y is equal to r sin theta, and dx dy is equal to r dr d theta. Fine. And x square plus y square, we can shift it as r square. So let's substitute this everything. Now this is a complete circle if you look at it. So complete circle, so this will be something like this, a complete circle, right? And it is x square plus y square is equal to a square, can be written as r is equal to a by root 2 in the polar form. So now the region of intersection in double is complete circle. So by region of symmetry, what you can do, you can take first quadrant by radial strip, and 0 to pi by 2 will be angle, and you can multiply by 4 because you have 4 regions same. So 4 into 0 to pi by 2 will do, right? So let's convert the sum now. So my volume V now will become 4 into 0 to pi by 2, that is my theta, 0 to a by root 2, right? And my inside integration, what is my inside integration? This will be x square minus y square. If you take minus sign common, that will become x square plus y square, which is r square. So that will be under root of a square minus r square, right? And this is minus r square dr. Okay, x square plus y square is r square and it is under root of r square this way. Okay, and this is also under root of a square minus r square. Fine. So my equation 1 will become this. If you convert into polar form, this becomes my equation 1. So let's simplify this to get the answer for the volume. So this will be 4 into 0 to pi by 2, 0 to a by root 2, and this is nothing but under root of a square minus r square into r, minus r into r has become r square dr. So now if you look at this properly, the inside integration, this you can use the formula of a square minus r square, you can multiply and divide by minus 2. So you can use the formula n plus 1 upon n plus 1, that formula. So if I multiply and divide by minus 2, the integration, I am not integrating around, let me adjust first. So I'll multiply this by minus 2 and divide this by minus 2. So now my integration of this will become easier. This I'll keep as it is. Okay, so now let me integrate this. I have used this formula over here. I hope you remember. Let me write it again. F raised to r raised to n into f dash or r. If we adjust something like this, then my formula will become n plus 1 raised to upon denominator n plus 1. So here now minus r square, the derivative is 2r, which is quietly nicely adjusted. So we'll have to use this formula now. Okay, so using this formula will give me 4 into 0 to pi by 2. It is minus 1 by 2. Okay, so that is a square minus r square 3 by 2 upon 3 by 2 minus r cube by 3. The limits of integration are 0 to a by root 2. Okay, so let's substitute the upper limit and the lower limit. Here integration is with respect to theta. So that is 4 integration 0 to pi by 2 d theta into, let me substitute the limits. So the limits here will be 2 will get cancelled and 1 by 3 will come outside, right? And let's substitute the upper limit minus the lower limit. So this will be 3 by 2 minus a cube, right? And this is minus a cube, the lower limit, that is 6 root 2, this way. Okay, so after simplification you will get this as 4 and this will be pi by 2, and if we simplify this, this will be what? Minus a cube 3 root 2, this thing, and this is plus a cube by 3, right? Further simplification gives me the final answer. So total volume is given by pi a cube by 3 minus root 2 plus 2. You can check the final answer after simplification. Take the next sum. Find the volume bounded by the cone. Cone equation is x square plus y square is equal to z square, and a paraboloid. So paraboloid equation is x square plus y square is equal to z, right? So now we can draw a cone and a paraboloid. So let us imagine how it will become. Let me draw the x-axis and y-axis first. Okay, so first you will draw a paraboloid, something like this. Okay, this way, and my cone something like this way. Okay, so now the area for intersection is nothing but a cone and a paraboloid common. So you can see very clearly. Right? So now what you have to do, the strip something over here. That means let us find, by the same logic, let us find the equation for z. What are the values of z? You can see clearly that it is touching this green. Green is nothing but your paraboloid. So my formula for volume is triple integration of dx, dy, dz. Right? So now you know that it is given in Cartesian form, and by the logic we are finding the values for z. Now what is green? Green is your paraboloid, and paraboloid is given by x square plus y square, which is your lower limit. And my cone, it is x square plus y square is equal to z, and my cone is what? Under root of x square plus y square, right? dz. And then I will integrate with dx dy. So my volume V will become nothing but x square plus y square minus x square plus y square dx dy. Equation 1, right? Where R is, what will be R? Look at both the curves. The intersection of the curve, what will be the intersection of the curve? That is x square plus y square is equal to 1. Right? So if we substitute one curve into other, we get x square plus y square is equal to 1. Now this is a complete circle, you know. So after you convert this into double integration, so this will be nothing but, now you have to convert into polar form as we have seen. So converting into polar form, what will be conversion of polar form? Yes, x is equal to r cos theta, y is equal to r sin theta, and dx dy is dr d theta. My x square plus y square will be r square, and the r is nothing but what? R is equal to 1. So this circle here is nothing but r is equal to 1. For a complete circle we have to find. So if we take a radial strip, and if we see it travels in anti-clockwise direction, so you'll have to write the angle 0 to 2 pi. If you don't write the angle 0 to 2 pi, take either you write angle 0 to 2 pi as outer limits, or you can write 4 into 0 to pi by 2. That means 0 to pi by 2. That means you can convert this into 4 region, 1, 2, 3 and 4 as we did in the earlier thing. So now my equation 1 will become volume is equal to 4 into 0 to pi by 2, and the inner limits are 0 to 1. So my inner integrand will become x square plus y square is r square. This will become r minus r, x square plus y square is r square, that is r minus r square and r. So r minus r square r dr d theta. So let's integrate with r first. It's a simple integration now. So this will become r square minus r cube. The limit of integration are 0 to 1. Right? So let's integrate with respect to r. So that will become 4 into 0 to pi by 2, r cube by 3 minus r raised to 4 by 4 d theta. So my final answer here will become 4, 0 to pi by 2, right? So 1 by 3 minus 1 by 4 d theta, which is nothing but, if you simplify this, you will get final volume as pi by 6. Okay, so by the same logic, that is, you find the value of z and then you integrate, you get the answers. Let us continue. We'll take more two sums so that you get a proper idea of what we are doing. So we'll take the sum where now the region is bounded by the cylinders and two cylinders are given. So the question is, find the volume bounded by the cylinders x square plus y square is equal to 2ax. This is one, and the other is z square is equal to 2x. Now drawing two cylinders and checking the boundedness is really not possible on the page, and it won't be feasible for you. But here clearly we can see that from one equation, this is a Cartesian, so we can write in dx dy dz. So here clearly we can see that from one equation, that is z square is equal to 2ax, I can get two different things. So z will be nothing but plus minus under root of 2ax. So that will be my innermost limits. So this volume can be written as innermost limits of z minus 2ax and plus 2ax dz, right? dx dy, which can be simply written as 2 into 0 to a, right? Because you know that it is a property of integration. Minus a to a can be written as 2 into 0 to a. So we can write this as 2 into 0 to a. So let's integrate this, and my triple integration now will be converted into double integration. Okay, so this is, I named this as equation 1, right? And then this equation 1 is over region, the another cylinder, the another curve. So now, but it is in two-dimensional. So this equation is of a circle, and you know it very well. Let me draw that circle. Y is equal to 2ax is a circle on x-axis. Okay, something like this. And then you take a strip, right? And the limits of integration, you know it is minus pi by 2 to plus pi by 2. If you take only one part, now this part and this part is symmetric. So if you take only one part, you can write it as 2 into 0 to pi by 2. You can write this also, right? So this, if I convert it into polar, so my this curve will become what? R is equal to 2a cos theta. You know, we have seen the standard limits of some curves. In that we have seen the limits of this. So if I converting into polar, my equation 1 will become volume is equal to what? You have 2 into and one more 2 into 0 to pi by 2, because I am converting into 2. So 0 to pi by 2, 0 to 2a cos theta. Okay, and what do I have? 2ar cos theta raised to 1 by 2. So 2 is again same, a is there, and instead of x we will substitute r cos theta. So you will have 2ar cos theta raised to 1 by 2 r dr d theta. This is what your equation 1 will become, right? So now let's take some things common. You will have 4, your 0 to pi by 2, and you will have some, let me separate this and then we will integrate. So 2a raised to 1 by 2, again this is a constant, can be taken outside. Cos theta raised to 1 by 2, you will have this r raised to 1 by 2, and r will become r raised to 3 by 2 dr. Okay, so now we will integrate this with respect to r. So what you will have, 4 0 to pi by 2, 2a raised to 1 by 2 is constant, cos theta raised to 1 by 2 is also constant with respect to r. So my integration is just 0 to 2a cos theta r raised to 3 by 2 dr. Only this simple integration is there, right? So r raised to 3 by 2 can be written as r raised to 5 by 2 upon 5 by 2, and you substitute this cos theta, upper limit and the lower limit. So 2a raised to 1 by 2, cos theta raised to 1 by 2, and this is r raised to 5 by 2 upon 5 by 2. So let's substitute 2a cos theta raised to 5 by 2. So that again raised to 5 by 2 you have, and here 1 by 2 you have. Let's simplify this. Take the limits 4 here, and this 2a raised to 1 by 2, 2a raised to 1 by 2. Let's take the constants outside. So this will become 8 anyway. This is 8. Okay, and 2a cube raised to 5 will come outside. Inside you have 0 to pi by 2. This cos theta raised to 1 by 2 is there. And here you have cos theta raised to 5 by 2. Right? So this 1 by 2 and 5 by 2 will become cos cube theta. So you will have 64 a cube raised to 5, 0 to pi by 2 cos cube theta d theta. Okay, we have the reduction formula. After you use the reduction formula and simplify, your final answer should be 128 a cube by 15. You can check the answer by applying the formula. We have done that earlier also. Okay, so this should be your answer. So the sum is too easy. First, again with the same logic, we found out, and then we found the double integration. Next, find the volume in the first octant. As I have told you, what is the meaning of octant? In 2-dimensional you have a quadrant, in 3-dimensional you have an octant, bounded by a circular cylinder. Again, drawing this is not very feasible. We won't draw the diagram for this. We can directly imagine. And the planes, are z is equal to x plus y is equal to x, z is equal to 0, and x is equal to 0. Right? Fine. So now I won't draw the diagram. I'll write the formula for the volume in Cartesian form. It is dx dy dz. Right? So now what you have, whenever you have the limits of z, as by the same logic, what you do, you take the constants for z and then we apply that and we solve it. So this will become the limits for z. It is clear, it is 0, and this is x plus y. So that will be 0 and x plus y. Right? Now this will be the constants for my z. And dx dy. So now what you will have inside is double integration x plus y dx dy. So now if you look at it, the integrand inside is x plus y. It is nowhere, if you convert, you won't get r or something inside. So we won't convert this into polar form. So converting this into polar form is really not beneficial for us. So now what we will do, as we solve my double integration sum, that way in xy plane, this won't be converted into polar form. In my xy plane, let me draw the circle x square plus y square is equal to 2. Because the curve that they have given, you can check. It is x square plus y square plus 2. This one curve remains and y is equal to x. These two curves remain. So let us plot these 2 points. Okay. So this will be what? X square plus y square is equal to 2. And then y is equal to x. This is my y is equal to x. Now the region of integration that is bounded by these two will be this. Right? So if I take a strip which is parallel to my y-axis, so here it is touching the line y is equal to x. So my lower limit will be y is equal to x and upper limit will be what? Y is equal to under root of 2 minus x square. Now this is nothing but 0, 0, you know. And my limits for this, that is my point of intersection. If you substitute one curve into another, that is if you substitute y is equal to x here, you will get 2x square is equal to 2. So x is equal to 1. So the point will be 1, 1. Right? So my triple integration is converted into double integration. So my points is 0 to 1. Here it is 0 to under root of 2 minus x square and x plus y dy dx. First we'll integrate with y and with respect to x. Okay. I did not convert this into polar form as I did for the rest 2-3 sums that we had taken in the previous part. Why I did not convert is, you look at the integrand inside. The integrand inside is x plus y. And it is not x square plus y square, or you won't get r. So converting into polar form won't really help. So I'm not converting into polar form. I'm keeping the sum in Cartesian form. Okay. So it's not necessary always that my double integration should be converted into polar form. So let me integrate this with respect to y first. So that will be 0 to 1 xy y square by 2 0 2 minus x dx. Right? So after integration, this will be 0 to 1. Let me substitute the limits in place of y. Right? So that will be, and let us integrate this. Substitute the upper limit and the lower limit. Sorry, the lower limit is not 0. It is touching the line y is equal to x. So by mistake I have written 0. You can just change this as x. Because my strip is touching y is equal to x. Right? So, no, this is 0. Here it is not 0. Here I have written 0. Here it is x. Okay? So, upper limit and lower limit if you substitute, let us simplify this. You will have under root of 2 minus x minus 2x if I'm multiplying and dividing, right? And then you have this as 2 minus x the whole square. So after simplifying, I'm getting this, and now I have to integrate this with respect to x. Okay, so let's use this for, why I have done this minus 2 and plus 2, because I have to use that formula. N plus 1 upon n plus 1, that formula I have to use. Okay, so if I integrate this, what I'll have, minus 1 by 2 as it is. The integration for this is 2 minus x square 3 by 2 raised to 3 by 2 plus x minus 2x cube by 3. The limits of integration are 0 to 1. So after I simplify this, substitute the upper limit and the lower limit, you can check my final answer should be something like this: 1 by 3, 1, 2 by 3 plus 2 root 2 by 3. So after I simplify, my volume is nothing but 2 root 2 by 3. This should be my volume. You can check the answer if you want. Okay. Fine. So these were the sums that we took on volume. Some sums we have converted into double integration and then we substituted. Some others we directly did by Cartesian form. If some sums we get that a standard curve is given to you, that is your complete sphere or something like that, then you can use the standard limits that we used in spherical polar coordinates and then use the formula for the volume in my spherical polar coordinates and get the answer. So anyway, the application part, that is volume, is nothing new but just an extension of your triple integration part which I took when the limits of integration were not provided.